All right, welcome to the first day of our unit. Today we are starting a new unit on ratios and proportions. It follows the 6th grade unit on ratios and unit rates. So lesson 1 is an experience in the relationships as measuring rate. So we're going to be talking about measuring rate. If you were in class instead of watching this video, you would go through an experience where I passed out some papers to you and we are going to figure out how fast our class was. So we would do 4 different trials where we would take the number of papers passed and the time, and then we would write that ratio and figure out the rate and the unit rate. So an example of what that might look like is something like this, where when we first started passing out the 24 papers, it took us 12 seconds. But as we continued, we were getting, just like anything you practice, you get faster and faster and faster. So the ratio of the number of papers passed to the time is 24 to 12, or we could write an equivalent ratio by reducing 2 to 1. For the second one, 24 to 11, we can't simplify that. So we'll just leave that. 24 to 10, 2 goes into both of them, so we can simplify to 12 to 5. And then 24 to 8, so to write that ratio, it's the number of papers passed, so that's going to be our first number, to time. So 24 to 8. And then what can we simplify that to? Think about if we were going to simplify, what would that be? What goes into both numbers? 8 goes into both numbers, so 8 goes into 24 3 times, and it goes into 8 1 time. So because it's a ratio, remember we have to have 2 numbers that we're comparing. And remember, to get the rate, so this is the ratio. The rate is a per 1. So because we're talking about time, and this was measured in seconds, for the rate, we are trying to get the numbers, so it's per 1. So how many papers can be passed in 1 second? So the rate for this first one, it is already simplified to a per 1, so it was 2 papers per 1 second. So that rate always has a per, or how many per 1. And the unit rate is how many per 1, so the unit rate for that would just be 2. So pause for a minute and see if you can figure out the rest of these. The next one was a little bit more difficult because it was not already to a per 1, and the third trial wasn't either, but this last one was easy, so hopefully you at least got this one. It was 3 papers per 1 second. So our unit rate was 3. With trial 2 and 3, you had to do some dividing. How many times does 11 go into 24? So I think of it like, and I'm going to write it up here. I think of it like a fraction, 24 over 11, and we want to change it to the per 1. So we have to divide. 11 goes into 24 approximately, so about 2.2 papers per second. So you can see that we're getting faster by about 0.2 papers per second. So our unit rate is 2.2. And 5 goes into 12 2.4 times. So for the third trial, 2.4 papers per second. So our unit rate was 2.4 4. All of this hopefully is a review from when you were in 6th grade. So we talked about what a ratio looks like. The rate is again always per 1, so it's comparing two numbers, but the second number is always 1, and then the unit rate is what number is per 1. All right, before I continue, I want to just remind you of the key terms that we just talked about from 6th grade. The ratio is the ordered pair of numbers, and the order of them matters. The first number is the A, the second is the B. So our first number for that last example was the number of papers, and B was the number of seconds. So it's really important that you always keep the same order. The two ratios, if we had A is to B as C is to D, they're equivalent. So, for example, we did 24 papers to 12 papers, and we could write the equivalent ratio to papers for every 1 second. I think I said this first one wrong. 24 papers for 12 seconds, and we can reduce that to have the equivalent ratio 2 papers for every 1 second. We also talked about how ratios can be written as rates. So the example here, 5 miles per 2 hours, can be written as a rate, and the rate is where it is over 1. So in 1 hour it can travel 2.5 miles. And again, how we come up with that is 5 miles for 2 hours, and we can reduce that to 2.5 for every 1 hour. And the numerical part of this in the front is called the unit. So this is the unit rate, and this part is the unit. All right, if you were in class, this is when we would do another activity by counting up the number of boys and girls in our class and writing a ratio, and then writing pairs of equivalent ratios by comparing. So again, I'll pause and get some data for you, and we'll look at it. All right, so here's an example. So class 1 is a little bit of a larger class. There's 26 people in the class total. And so our ratio, we could write it as 14 to 12, but we really like to have things simplified. So our ratio, when it's 14 boys to 12 girls, is 7 to 6. And we can look at class 2. Class 2 is a very small class, and there are 7 boys and 6 girls, and that's already in simplest form. So we would also write that 7 to 6. 7 boys to 6 girls, and notice the order matters, boys to girls. The whole 7th grade we're going to talk about in a little bit. So if we looked at all of the 7th grade in your building, what would that look like as far as the number of boys and the number of girls? All right, so I added some data here. So 3 more classes, and I would like you to pause and see if you can figure out the ratio of boys to girls for class 3 and 4, and then really stretch yourself and see, given the data here, if you can find how many students of each gender are in class 5. So pause and see if you can do that. All right, hopefully for class 3, you wrote 16 to 12, but reduced it's 8 to 6, and then we could reduce even further to 4 to 3. So that means it's telling us for every 4 boys, there are 3 girls. And in both classes 1 and 2, there were more boys than girls. So this makes sense. We get to class 4, though, and it's reversed, and we can't simplify. So 10 is to 19. So for every 10 boys, there are 19 girls, which evens out the other class, where there are more boys than girls. So, did you challenge yourself and find these numbers right here? The easiest way to do that is to total all of these, and then how much would it be to get to 55? So, for example, 14 plus 7 plus 16 plus 10 is 47. So 55 minus 47 is 8. And if we do the same thing for the girls, we come up with 16. So that is 1 to 2. So 3 of the classes had more boys than for every girl, and then 2 of the classes had more girls for every boy. So what does that mean for the overall grade 7? There were 55 boys and 65 girls, so we could write that ratio, 55 to 65, and then when we reduce, we come up with the ratio of, because 5 goes into both of them, 11 to 13. So we're seeing here that there are more girls than boys overall, but we then can compare. So this one has a larger ratio, and a larger ratio, and a larger ratio, but these two had smaller ratios. And then overall, they come up with the overall ratio, or rate. If we wanted a rate, we could actually do that division. Alright, for this next problem, we're going to try to figure out which is the better buy. This is where I see math like this, math with ratios and rates, used most often. You can't be a good smart shopper if you don't know how to do this type of problem. So let's first read the problem together. Value Mart is advertising a back-to-school sale on pencils. A pack of 30 pencils sells for $7.97. Where a pack of 12 of the same brand, so they're the exact same thing, is $4.77. So which is the better buy, and how do you know? There's a couple different ways to go about this problem. The reason we can't just stop here and look at these two numbers and say, oh, this one is the better buy because it is less money, is because you're also getting less pencils. So we need to put them in equal amounts. We need to say, okay, 30 pencils and 12 pencils aren't the same, so we need to get the same number of pencils. So let's first look at what we know. We know that it costs $7.97 for 30 pencils. And we know that it costs $4.77 for 12 pencils. So now we have to put these numbers as like numbers so we can compare the same amounts. So 30 and 12 both go into 60. So let's figure out how much, if we are buying multiple packs, how many packs would we need to get to 60 and how much that would be. Well, if we were buying the 30 pencil pack, that's only 2 packs that we would need. So $7.97 times 2 is $15 and 94 cents. And 12 goes into 65 times, so we would need 5 packs. We would need 5 packs. So $4.77 times 5 is $23.85. So doing it this way, we wrote ratios with the same amount of pencils. And now we could definitely see, well, the 30 pack is a much better deal because look at overall the cost. So our justification, how do we know? Well, we know that for 60 pencils, it's $15.94, which is considerably less, almost $8 less than if we were to buy the same number of pencils of the 12 pack. So that's one way. The other way is we could make unit rates. You could compare per one. Remember, the unit rate is per one. So you can do some division to figure out how much would it cost for one pencil. That's the unit rate per one for one pencil. So we could divide, if it's $7.97 for 30, how much would it be for one? So we could do that division, and it is approximately 27 cents. So again, how I did that, I just divided $7.97 by 30 and came up with approximately 27 cents per one pencil. And I could do the same thing over here. I could do 4.77 divided by 12, and I would come up with, it is 40 cents per one pencil. So again, looking at the unit rate, we can see that it's only the per rate, the unit rate for one pencil is much less in the 30 pack. So I definitely would buy the 30 pack, especially because we're always running out of pencils in math class. So you can see finding the unit rate was extremely helpful in being able to show this comparison, which one was cheaper, which one was a better deal. So in conclusion, what we talked about today was unit rate, and unit rate is often useful as a means of comparing ratios and their associated rates when measuring different rates. So the unit rate allows us to compare varying sizes by examining the number of units per one. So the value of the ratio is the unit rate. So you have to divide it to get it to the per one, and that's the unit rate. And once it's in the unit rate, it's easier to see which is the better buy, or which is more, or which is less. So now I would like you to spend some time doing the problem set. The problem set is where you practice these concepts on your own. So the first one, you are just finding the unit rate, the rate and the unit rate. So remember, the unit rate is how many per one, and then the rate is the number that is the first number when it is per one. Then you're going to write three ratios that are equivalent to this. So this is the number of right-handed students compared to left-handed students. What are three ratios that are equivalent to this one? And then the third question, Mr. Rowley has 16 homework papers and 14 exit slips. And it gives you some information about Ms. Rivera. And for each teacher, you're going to write a ratio to represent the number of homework papers to return and exit slips they have to return. So homework papers to exit slips. Are they equivalent? Explain. And then lastly, you have some more practice problems. Make sure you read the questions carefully. Pick out those important numbers. Make sure you're understanding what it's asking. There's only 7 problems, so this shouldn't take you too long. Good luck.